So today's brief is going to be beyond labels, why relationships and constraints matter for reasoning in AI systems. And the audience for this brief would be uh, section chiefs for an agency like the FBI or the DEA or some law enforcement type agency. So we start off with why semantics matter. And so what you're going to see right now is you're going to see this playground over and over again as we kind of tell this story of semantics and why they matter. And later in the brief, we'll get into how they affect LLMs. But the first thing we have to realize is that ambiguities exist everywhere. So in the middle of the screen, you see the word play. And human beings can easily understand that we're associating play with the playground. It probably means children running around and having a fun time. But computers are a little bit more literal. They're not going to really understand. So if you have an LLM that's just going to start trying to build tokens to understand this and figure out words, it could hallucinate because maybe your system has multiple meanings of the word play. So meanings require structure and labels really aren't just enough. So here we have same word, different things, and labels alone don't really ensure shared understanding. So as you can see, all three times this word play is an alternate label. For one, it's football play, like how to score a touchdown, and the coach writes up a play. And then we have a theatrical play that's going to be with dancers or actors on a stage. And then at the bottom, we have unplanned play. And that's an unplanned act where agents engage in spontaneous physical activities for recreation without structured rules or objectives, fostering enjoyment and social interaction. Obviously, this is what we would want the system to pick. And so when we create reified strings out of a knowledge graph, we want this type of label to be going into the LLM so that it can understand, oh, this is the version of play that I want to be associating this picture with. So here we also have different words, but they're the same thing. So we don't really have to all live by the same label. So it doesn't matter if you're in Beijing or you're in Detroit. If you understand what a swing is, you can use different labels. The same thing with the slide. It doesn't matter if you're in Riyadh or you're in San Francisco. As long as you know how to use a slide and you understand that's a slide, that's what's important here with the label. You can have multiple labels. And then sometimes it might be tribalism. And in a lot of our agencies, we have tribalism. And so here we have a seesaw. That's what I called it. Now, my mother, she might have called it, a teeter board, and her mother might have called it the teeter-totter. But what we don't want to do is confuse these as different things. So we can have different labels showing that they're the same thing. And again, we can have the same category of things. So here we're showing an ISA relationship, which is a subclass relationship from playground equipment. So they all belong to the same category, but that's really not enough. But it does help that we can now start to have this idea that we're building almost a taxonomy of things. But what's really important and what's going to drive your AI systems to be so much better is really having constraints. Constraints are really important. So here everyone in this room can tell that, this is playground equipment, but these are all different things. But we have to build that constraint into our system so that it understands that these are disjoint with each other, which means they're not the same thing. So, the same group, not the same thing, and the semantics make it clear. And when you combine this, it really shows how ontologies help because we have the playground equipment and we have almost this shape that is being made with relationships between the swing and the seesaw and the slide. So ontologies really help organize this shared meaning and enforce, what things aren't and what things are. So if we bring this over to something that is more applicable to a law enforcement agency, we still have this why semantics matter concept, and every organization, again, deals with ambiguities. So here we have the word travel, and we can kind of start associating, but here it's a little bit more unclear. We don't really know what they're talking about. And we don't know what they're going to be talking about from what the law enforcement agency is going to really care about. So here we have, again, same world, different meaning. We have 3 times that we have the word travel, which is an alternate label. One time it's an act of commuting. It's probably not something that we're going to worry about. And then we have an act of air travel, probably again, something that we're not going to worry about. People are law abiding. And then the third one, we have active illicit narcotics run. So if someone wrote down on their form 6 or, whatever form they're filling out that so-and-so is traveling here to deliver drugs, what we would want to have is this idea that, oh, this is the alternate label they're probably using. We don't want to confuse that because we want to make sure that the ontology, can help the detection systems know which travel is a narcotics run. So if we look at these items that are, on the screen and we have, a boxcar or a cargo truck, we have a human being in the middle who, certain law enforcement agencies might call them a mule or a body packer or a foot carrier. And then, if you're trying to, move illicit drugs via boat, you might call it a go fast boat or a cigarette or a panga. But either way, if it's a risk if we don't get these labels right. And what we want to make sure is that the FBI or if local law enforcement or the DEA or anybody is using a certain word that might not be within the culture of that agency, that we can still understand the data that they have because they have our word and their word, and those are alternate labels, but the system can understand that and bring it in. And so again, same category, travel alone really means nothing. But here, instead of having them be a subclass, because travel is really a process, it's an act of traveling, we have a relationship which has participants. So all of these 3 things could be a participant in traveling. And so what we have here is we start to understand a little bit more about what's going on with the context. And then we also want to make sure that we have this same disjointedness. Now, it's easy for human beings to understand that a boxcar or a truck isn't a person or, a mule or, isn't a boat, but the system might not understand that. So each thing travels, but not with the same method or the same implications. The last thing we'd want our AI system to do is to start giving us responses that would be used for, say, a mule or, a guy with a backpack going across the southern border, when in reality, we need somebody who can catch a boat in a high-speed chase. And so again, same world, different things. This really shows the system needs boundaries, and ontologies can really draw those boundaries. And what we're really trying to get at is that if we want to use LLMs in the future, and we want to make sure that they're not going to hallucinate as much, and we're going to be able to shrink down, the window of opportunities for them to hallucinate, semantics really reason. So LLMs can do some things really great, right? They're really great at working memory. They're really great at procedural memory, but they're really bad, but they actually don't even do it at all at associative learning or semantic memory. So, this strong memory at work can be for short-term token recall, procedural fluency with text generation, but for understanding roles and constraints and types, they really lack this ability, as well as associated reasoning, linking past outcomes. This creates a huge amount of risk. What we don't want to have is that an LLM treats a drug trafficking pattern the same as it would a financial transaction anomaly, because they think they're interchangeable phrases because they're both listed as dangers or they're both listed as risks. So we want to make sure that, we understand the LLMs, can't really generalize outcomes unless it's explicitly coded. And so what we really want to do is we want to give it an ability to reason. And so we want to give it a knowledge graph that's built with really good sound ontologies. And so this creates a semantic scaffolding. And that semantic scaffolding is going to be able to define valid entities, roles, and constraints using, web ontology language, OWL, and shapes constraint language, Shackle. And here we're going to be able to provide integrating formal ontologies will really give them an ability to track behavior over time and across contexts. And the takeaway here really is that LLMs can really generate fluent responses, but they really lack structure, memory, and meaning. So we can give them the memory in the form of the knowledge graph, so they can use that knowledge graph, and then we can really give them the structure in the form of that ontology in the knowledge graph. If it's built, to define things that exist or how it's related or what rules apply. And then by anchoring outputs in semantic scaffoldings, organizations can gain an AI that's not just generative, but will be explainable and accountable and hopefully will align to their mission outcomes. Thank you.